So let us try to solve another problem. So just go to new and give a file name and choose the location of the file by clicking the browse option. Select the analytical type and select the units English. Now click on the create. Go to grid option, click on beam grid. Now we have the grid, but we need another grid line. That's why click on the create. Now from the drop down list, click on select the irregular option and give a file name. Give the irregular grid system name. Now select the plane XZ and put the value of X. Now we are going to solve a simply supported beam which is subjected to a UDL. So suppose the beam length is 8 meter. So put the value 0 space 8. Now click OK. Now check the irregular grid system. Now click the first node of the grid and then click the second node. Now click the beam grid option to invisible the grid option. Now this is the beam and we are going to put the properties of the beam. So click on the properties, click on define command, select the rectangle option, put the YD value, say 500 millimeter, and put ZD value, that is width of the beam, say 300 millimeter. Material is concrete. Click on add and close the dialog box. Now the beam is selected. So assignment method is use cursor to assign. Click on assign option, select the beam. Again click the assigning option. Now go to support option, create a support, and we are going to create pin support or hinge support. So you can see this is the pin connection or hinge connection where Fx, Fy and Fz are restrained and moments are free. So click on add. Again you create another support, that is a fixed support. So I am going to apply the fixed support at one node and the hinge support on the another node. So click the support 2, that is hinge support, and I am going to assign this support at that node. Okay. Now click the assigning option. Again select the support 3, that is fixed support. Click on assign and assign the support on the other node of the beam. Now we have a beam with support condition. Now apply the load. So click the loading, select the load case details, click on add button. The primary load case is selected, number is 1, loading time should be dead load, and just type any name. Click the add button. Now click the close button. Now select the dead load. Again click the add button and go to member load. Here you can find different kind of loads. So click the uniform force. It is already selected by default, and this is actually the UDL, uniformly distributed load. Now put the value of uniformly distributed load here, the value of W1. So I have to put minus because it is downward force, and put the value say 30 kilonewton per meter, and keep D1, D2, D3 0 because we are going to apply this amount of load throughout the beam. Make sure that the direction should be global y direction. Click on add, click the close button. Now select the load, use cursor to assign this load on the beam. Again click the assigning. Now my model is ready. Click on analysis, click define command, use the static check, add, close. Now click on post analysis command, click the define command, select joint displacement, add member force, add support reaction, add. Okay. Now close it. We have assigned support for both joints. Okay, that's why the joint displacement will be 0 actually. So you can see, or you can neglect it, no issue. I am assigning the joint displacement for that portion. Now select the member force, click on assign button, select the member. Now click the support reaction, click the assign button and assign the true support condition. Again click the assigning. Now the final step is run analysis. Save, 0 error, 0 warning, 0 note. So go to post processing mode. Okay, we have only dead load. Okay. Now this is the deflection of the beam, deflected shape of the beam. You can see the green color line. You see, for the fixed beam, the slope is 0, but for the hinge portion, there is some slope at the end of the beam. So if you want to see the shear force, click on F5 button. It will give you the shear force diagram. And if you want to show the bending moment, so click the MZ button. This is the bending moment. So this point is fixed and this point is hinged. That's why this is the bending moment diagram. And click on the reaction. Okay, those are the reaction. Now if you want to see the report, go to the report option and you can see various different result. So node display. So if you have to select the node and go to node displacement. So now you have to choose the direction or translational or rotational, what type of displacement you want. And to see the rotational displacement about z-axis, yes, 0.228, it is the z rotation, 0.228 radian. This is the slope. At the hinge support, the slope will be started from the end of the beam. If you select the another node, that is fixed support, you can see the rotation will be 0. Now select the node, go to the report and node displacement, select the z rotational, click OK. You can see the z rotational value is 0 because it is fixed. Now select the beam, go to reports and beam stress, and bending about z axis, select the bending about z axis, click OK. You can see for different section we have bending about z axis value, and shear value is also there. So to go to the modeling page, click on the analytical modeling. This is the beam. One thing I want to show, suppose some of you may face any problem regarding load. You may face various problem regarding this diagram. So to see the beautiful picture of this diagram, select the load, go to level setting, select the scales, take the apply immediately and change the scale of the load. So this is UDL, that's why we have to change the distance force. You can see the difference. Click OK. Suppose you want to know the length of the beam. So go to utility, select beam tools and select beam dimension. Now check the display option and dimension to view. Click on display, it will show you the length of the beam. Now to remove it, select the remove option and click on the remove button. The other procedure to show the dimension is node to node distance. Click on the node tools, click node to node distance, select first node and select the second node. It will give you the dimension. To remove it, again go to node tools, and click the remove node to node distance. Now if you click the command file, you can see the command file here. This is the command file of STAAD Pro. You can see the unit is feet and kilopascal. So just change it kilonewton and meter. Now save it and close the command button. You can see the unit is changed. So go to utility, go to beam tools, select the dimension beam to display the beam length. Now it is 8 meter. It's okay. I am opening the command file again. You can see the unit joint coordinate. This is this one means first coordinate and the value of coordinate is 0, 0, 0. This is the second coordinate, the value is 8, 0, 0. That means 8 meter length along x axis. So first value is x value, second value is y value, and third value is z value. The member is 1 and one member created between node 1 and node 2. This is node 1 and this is node 2. And material type, Young's modulus, Poisson's ratio, density, etc. is automatically calculated by the software. Now member properties is there, YD value 0.5 and ZD value 0.3. Now support condition that you have created, one is pinned and that is fixed. The load type is dead load and the value of load is -30 according global y direction. So you can edit this programming and you can change whatever you can do. Now let me try one thing. We have two support and both are different support condition. One is fixed and that is hinged. Now I want this support condition as a hinge support. So just go to there and edit the fixed to hinged. And we don't want joint displacement. Suppose we don't want joint displacement. Just select the line and delete it. Now save this, close it. This is a new model. You can see both are hinge joint, and now we have to again analyze the structure. So click on analyze and design. You can see that the joint displacement is command is not there. Click on run analysis. 0 error, 2 warning, 1 note. So to see the warning, go to output file, view output file. This is the output file. So zero error, true warning is there, and true message. So warning 1 is a soft material with this times of the stiffness of, and second warning is instability of the joint 2. You see, we have applied one, both are hinged connection. Okay, so that means this is not a stable connection. In one direction it is not stable. In y direction it is stable. Say it is z direction it is stable, and but in y direction it is not stable. If you apply an axial force, it will move. That's why STAAD Pro says that this warning. So this is the report. You can see all the details are here: x value, y value, and z value of the applied load. You can see the reaction, the maximum displacement, the shear force value, the support reaction, all reports are there. So go to post processing mode to see the graphical representation of the result. Click OK. Now you can see the elastic curve of the beam. Both hinged support are there. So there is some slope at the beginning of the end. Okay. So both have some slope. No zero slopes are there. So if you select this point and go to report and go to node displacement and z rotational, click OK. You can see the rotational value is minus 0.451 radian. So this is clockwise rotation. So that's why it is minus. And click the select this second node. Go to report and node displacement. Select the z rotational. Okay. You can see this is plus 0.451 radian. That means it is anti-clockwise rotation. So anti-clockwise rotation means positive, and clockwise rotation means the negative value. You can see the reaction also. So if you want to see the shear force diagram, now this is the shear force diagram. If you are okay with this diagram, no issue. But if you are not okay with this diagram, go to scale and click the apply immediately and change the scale of the shear force. So we have shear force along y axis. So shear y value will be changed. You can see the value will not change. Okay, value will not change, only it will scale up or scale down the diagram. Just it will just scale up or scale down the diagram. The value will be the same. Now if you want to see the bending moment diagram, click the MZ and go to scale, go to apply immediately and change the bending Z value. It will scale up or scale down the diagram only. To go to modeling mode, click the analytical modeling.